Hello all, welcome back to my channel. In this video, we'll be talking about Auth grant flow, which is a very popular token grant flow that is used in Azure Active Directory. While we're talking about this concept with respect to Azure Active Directory, please note that this concept is also relevant for other identity providers which use the OAuth protocol. Now, an interesting thing before we get started is Auth grant flow is for a user client that supports redirection from IDP to the resource provider. Now, if the terms IDP and resource provider do not resonate with your learning, then let me explain some key terms which are a part of the entire ecosystem of token grant flow with Auth core token grant flow. Now, the first one, which is a part of this ecosystem, is user, which is typically you who is going to authenticate and who is going to access sensitive resources inside an application. Then we have a browser, which is it can be a browser or it can be a native application, which is a thick client application inside your system, or it can just be a browser like Chrome, Edge, or Firefox, etc. And then we have a resource provider, which is either a SaaS application or an API which leverages identity provider as Azure Active Directory. So it decided that I'm not going to implement my own authentication mechanism, but I'm going to leverage Azure Active Directory as an authentication mechanism. That is what a resource provider is. And identity provider is what stores your identity and which is what issues tokens, authentications, and authorization instructions on behalf of you, which is a trusted authority to validate your that you are you. It is what IDP does. Now, in a typical authentication code token grant flow, the user is going to visit a specific application, whether it will be a browser or a thick client application, and then the user decides to go to a resource provider. So when you click on office.com, this is what happens. Using your browser, you click on office.com, or you decide to go to Dropbox, or you decide to go to any other any other SaaS applications which are leveraging Azure Active Directory. And once you go to a resource provider, the resource provider will identify that you're not logged in, and the resource provider is going to redirect you to an endpoint called authorize endpoint. So we will talk about these endpoints. They are available in your Azure Active Directory in the application section. So you see here is an application. You would just have to click on this button called endpoints inside an application detail view, and you will see the endpoints that I'm talking about. This is the authorize endpoint that I am going to call it slash authorize and slash token. This is for OAuth 1.0 OAuth 2, and this is for OAuth 1. Now, getting back, when the resource provider is going to send a request to authorize endpoint, it is going to use client ID, state, code challenge, and a couple of other parameters. Now let's go in detail about each parameter. Now the first one is client ID. It is something that is available in your Azure Azure portal inside applications inside the overview. Let me just quickly pull up the screen. So here you have the application client ID. And this is what the client ID, when I say application client ID. And we also have state code challenge. So these are two parameters that are generated by the resource provider for security reasons. State parameter is what kind of like protects the application against CSRF applications and token reuse. For example, so how the state parameter is generated is it's just a random alphanumeric characters with a specific length. During the first request, the resource provider is going to send this along to the authorized endpoint, and while sending the token in the last phase, this particular state and code challenge token are returned to the resource provider. This will ensure that any request that is coming from IDP is actually something that the resource provider has requested for, and it is not being reused from a previous request. Now, in this case, state is completely random alphanumeric characters, and code challenge is basically there'll be some random characters, and there'll be a hash function of that random characters. this hash value is sent as code challenge, and there is also another parameter called challenge method. In the challenge method, what is the hash function that was used to generate this hash is actually sent, and in this case it is I think it is SHA-256 is what is supported by Azure Active Directory. So when you are sending this code challenge, you would send this particular random hash value of the random characters, and you'd also send the challenge method. This is to again, avoid certain security attacks against the OAuth mechanism. And we have response type as either as a code or fragment. This is something that we will be discussing in the next step, but there are two ways in which this flow can go. And then we have redirect URI, which is where after a specific app request is completed, the identity provider is going to redirect it to resource provider. So that is what the redirect URI is. And there is also a required scope. Now this required scopes is basically a scope of this particular token that is issued at the end. So for example, if for completing Office 365, like for using Office 365, you need to access Outlook APIs. So you would use Outlook's mail.read as a part of your scope and mail.write as a part of your scope as well. So your application might have several API permissions. For example, in the previous video, we have seen that in an application, you can have several permissions that are associated with this application. However, the tokens are again scoped to specific permissions that you request for. This is to avoid if the token gets lost, we can avoid sensitive data being leaked outside. And with all of this, once the resource provider sends a request to identity provider, the identity provider is going to redirect it back to the user and ask for authentication. The user is going to complete the authentication, and whatever scopes are present in this, the user is going to be presented with all those scopes for the first time. For the first time, the user is going to consent to it. For the next time, the user just has to complete the authentication, and the user is automatically redirected back to the identity provider. And also, whenever the scope changes or whenever there is a change in API permissions associated to these applications, the user is again asked for consent for all the scopes that the application is requesting for. Once the identity provider gets the consent of the user, that the user's credentials. So when you talk about authentication, it is username and password. So once the username password is done, this is which is authentication, and this is authorization. Once the authorization from a user perspective is completed, the based on the request, if the request is redirect to a specific with a code and redirect to a specific page, then the identity provider is going to redirect that particular request along with auth code. For example, the redirect URI might be something like office.com, and it will be fetch token fetch_token.php and code equal to something. So this particular redirect URI is already set in the application registrations. So if you see application registrations, you would see uh, inside authentication, you would see a redirect URI. So if you add a platform, you can say it's a web platform, and here you can give a redirect URI to this particular application. So you can simply say it is office.com. So you need to give wherever you are listening for this particular access token. So this is something similar to concept of a webhook, where you would actually have the redirect URI sent along with the token. Once you receive token at this endpoint, you can process this token for further processing. However, another case is you can, in case of single page applications, you don't want the redirect to happen automatically to resource provider. What you would do is you would give something called as response type is fragment, where the auth code is returned to the browser, and the browser is expected to send the auth code to the backend using JavaScript. However, just to note here is although this is like going in detailed at a low level, we're talking about HTTP requests. There is something called as MSAL, which is Microsoft Authentication Library, which has authentication libraries for multiple languages, which makes it very seamless for developers to integrate this. So although you're learning the authentication mechanism and authorization mechanism in a very like kind of at a very deep level, but again, it's highly abstracted in terms of a developer. Like a developer seeing it as completely different. Now coming back, now once the in either ways, the resource provider will receive something called as auth code. This auth code is again sent to a resource provider along with the token to the token endpoint, along with client ID, client secret, and the code verifier uh, with the redirect URI, and code is equal to auth code. Now, this client ID, client secret, redirect URI, we've already seen it in the Active Directory, Azure Active Directory portal. These parameters are sent to identity providers, and based on this particular identity provider confirming whether this client ID, client secret, and code verifier are valid or not. So this code verifier is what is related to what we were talking about here. This is what is called PKCE variant of auth code grant flow. Once the Active Directory Azure Active Directory verifies this particular information, it is going to redirect to the resource provider along with the refresh token and access token. Now the access token, as we've already seen, is a JWT token. Now, the access token is what is primarily used to access resources. So once the resource provider receives this particular access token, it is going to make requests to APIs such as Outlook API, Microsoft Graph, or other APIs which are using Azure Active Directory as identity providers. However, after some time, the particular access token gets expired. So then the resource provider, or maybe if the code is returned to the fragment, the refresh token is used to get a new set of access token. So whenever the access token is basically invalidated, along with access to you send a request to identity provider along with your refresh token, asking for a new access token, and the IDP will return an access token and a new refresh token. So the first refresh token that you receive is called PRT, where using PRT you get an access token and you get a refresh token, and that is how the authentication process happens all the time, without having to make subsequent requests or without having to disturb the user flow or user experience flow to the user. Now, from a security perspective, there are a couple of things that we'll have to take care of. First one to look at is, what if the user is able to hijack this reply URL, because that is where your authentication code is sort of received. This is pretty much valid in terms of several OAuth implementations. However, in Azure Active Directory, there is inherent security mechanism that was built with the help of whitelisting of these reply URLs. Now, this is done in the application console that I've shown you. Anywhere, if you give a redirect URI which is not a part of the redirect URIs that you have given while registering your application or while modifying your application, that request will be rejected and you will get an unauthorized code, unauthorized error. So that is one implementation that will disallow this attack to happen. There is another attack that is absolutely possible, is the resource provider itself being a malicious resource provider. Now what I can do simply is, because I have an Azure Active Directory access to it, right? For example, I can go to portal.azure.com with my account. I can create an Azure Active Directory application, and I can select a multi-tenant application that we have discussed in the last class. Using that option, we will be able to create a multi-tenant application. I can fish users to sort of give me access to APIs which I shouldn't have access to in the first place. Like for example, I can ask for mail.read and mail.write, although my application does not require any of that access. And if the user is fished into or is lured into accepting those permissions, then my rogue application will now have access to all those APIs with the user permission. This is mitigated in Azure Active Directory by ensuring that all unverified applications, so all applications by default are unverified. So if you need to get your application verified, you need to go into your Azure Active Directory application section, and you have a very simple verification process where you need to get registered with Microsoft partners, Microsoft Partner Portal, and you need to enter your ID, which is verified with your Microsoft Partner Portal. Using that, you will establish a mutual trust that now Azure Active Directory knows that your application is actually a verified application and is published by a verified developer. So in this way, this security issue is also mitigated. However, this might still apply to other OAuth platforms where this sort of mitigation is not present. Now, talking about the client secret, because whenever we talk about secret, there is very important aspect that comes into everyone's mind is, hey, what if this secret is stolen? Now this is a very interesting conversation to have. However, it will be more relevant for us to have this conversation in a client credential flow, which is what we'll be talking about in the next video. So see you there. Bye bye.